My name is Don Conger. I've been involved with developing mechanical integrity programs for nearly 30 years, 25 of those primarily devoted to managing and implementing risk-based inspection studies. This presentation describes the steps to define and document piping systems and piping corrosion circuits as part of a mechanical integrity program. Topics covered include why to define piping systems and circuits, how to define piping systems, and how to define and document piping circuits. Creating a piping system and circuit identification log is a good way to document the work. This log is for the number 10 depropanizer unit. Each system has a unique identifier, in this case a unique color. The systems are numbered 1 through 7, and the circuits in each system are labeled alphabetically. System 1 contains circuits A and B, System 2 contains circuits A through F, etc. It is beneficial to include the P&ID number on which each piping system begins, and each system requires a system description as shown on this example. Process piping systems are defined and identified on diagrams to organize the piping into manageable segments for inspection purposes. This technique is an alternative to inspecting piping by P&ID line number. Piping systems represent an assembly of interconnected pipelines built to the same design code and containing the same or similar process stream. Piping systems include the piping associated with multiple pieces of fixed equipment. Piping systems start and stop at pieces of fixed equipment that can affect the chemical composition of the process stream. The basic information needed to define piping systems includes the boundaries of the process unit, the chemical composition of the various process streams within the unit, and locations where the chemical composition of the process streams change. The stream compositions are obtained from heat and material balances associated with the process flow diagrams. As shown on this example, System 1 is colored yellow and provides the feed for the column. System 2 is colored purple and exits the column bottom. System 3 exits the top of the column. Each process system is highlighted in a similar fashion on the PFD until all are identified. The next step in this effort involves transferring the colorized systems from the PFDs to the P&IDs. In this example, System 3 is colored blue and enters the side of Vessel 1, then exits the top of Vessel 1. System 4 exits the bottom of both Vessel 1 and 2. Each piping system in the process unit is highlighted in a similar fashion on the P&IDs until all are identified. Once the piping systems are documented on the PFDs and P&IDs, the next step involves splitting the process-based systems into corrosion circuits, which are defined as a section of continuous pipelines exposed to an environment of similar internal corrosivity, similar operating conditions, and similar materials of construction. Circuits typically start and stop at pieces of fixed equipment. One exception is a spec change where the material of construction changes. Then the circuit may start or stop at a flange connection. Identification of piping circuits focuses on the internal potential damage mechanisms only. External mechanisms such as corrosion and insulation are not considered to determine piping circuits but are addressed during inspection. Injection points are placed in separate individual piping circuits. Circuits may terminate at control valves if the pressure change is greater than 50 psi. Information needed to define piping circuits include a set of P&IDs identifying the piping systems, operating parameters for the fixed equipment included in those systems, and pipe specs which reference the material of construction of the piping included in each system. Piping corrosion circuits are color-coded at the P&ID level as shown on this example. Circuit 4A exits the bottom of Vessel 1 and is colored yellow. Circuit 4B exits the side of Vessel 2 and is colored green. And Circuit 4C exits the bottom of Vessel 2 and is colored orange. Circuit breaks are identified with a hash mark at the control valve as shown. Each corrosion circuit is highlighted in a similar fashion until all the identified circuits are color-coded in the unit. The color-coded circuitized P&IDs can then be used as a go-by for creating piping inspection ISOs in the field, as well as for piping circuit data collection. For additional information, please contact us through this website or email. Thank you for your time.